In March of this year, my collaborators and I published on a new Tyrannosaur from Montana, and its name is Daspletosaurus Horneri, Horner's frightful lizard. We have adults, subadults, and we also have bits and pieces of juveniles. We compared it to other Tyrannosaurs and found it was most similar to an animal called Daspletosaurus, which is known from one species called Daspletosaurus Torosus, the bull-like frightful lizard, which is from Alberta. And Horneri and Torosus share a whole slew of features that they inherited from their common ancestor. Horneri is different from Torosus in terms of various features, primarily in their skulls, size of the horns, depth of their skulls, width of their snouts, and other features, which is evidence that they're different species. They're in effectively the same geographic region. Horneri is from Montana, Torosus is from Alberta. They're each other's closest relatives on the family tree of Tyrannosaurs. We found that Horneri lived later than Torosus, and they're actually separated by a gap in time, about 100,000 years. And what that implies is that Torosus, through the action of natural selection, may have morphed into Horneri, and this is an example of a type of evolution called anagenesis. Basically, one species morphs into the other through time without the classic splitting of an ancestral population into two daughter species. We also found evidence, direct evidence, for the life appearance of Tyrannosaurs, and that information was locked in the texture of the facial bones. It turns out that the facial bones of animals, like dinosaurs, birds, and crocodilians, are shaped by the overlying skin. So for example, scales leave little bumps. What we saw in Tyrannosaurs was evidence for a mask of flat scales covering the entire face, just like crocodilians. We also think, in addition to all of that Tyrannosaurs had hypersensitive skin on their snouts, given that they have these flat crocodile-like scales. And it turns out that living crocodilians have hypersensitive snouts, which are intimately connected with this type of skin of flat scales. So we think Tyrannosaurs were no different. In terms of that last point, what we've done is establish something called the null hypothesis for how dinosaurs actually appeared, or at least for how Tyrannosaurs actually appeared. And the true test of our hypothesis of flat scales will come from the fossil record. The day will come when a Tyrannosaur mummy will be discovered, and when that day comes, we will know whether or not we can really know the appearance of extinct animals based on the texture of their facial bones.